Yes, yeah, you may see this Ferdinand Dandy here, the transformer which convert the there is a 10% distortion. That's basically what's on my bench. It's more than 1 hour now since I started test, and also I increased the output to 6 volt RMS, and the power that we can get from the load should be around 4.5 watt. That is watt RMS. So at 4.5 watt, we can see the distortion that is set to 0.3, and that is about 0.18, or let's just say 0.2% at 4.5 watt. So I'm ready now to crank the power to its maximum. Let's see what's the maximum power that we can get from the Neyland amp prototype number 1 when the distortion at 1%. First, I'm gonna set the correct range of the distortion meter. If I need a 1%, then I need to set it to 1 or 3%. Well, I choose 3%. So the scale will be that is a 3% distortion. This is 2, and that should be 1%. So what I'm going to do in here is that I will increase the input signal until I can get a 1% distortion here, and after that I'm going to read the voltage swing at the speaker load, or that is the resistive load. So I expect that the voltage swing as well will be increased, so I'll put it to 30. That's the setting for the signal output. And there you are, got 1%, and that's it. And that is the signal waveform at 1%. Take note of that. And what will be the power at the time? That is a 47 watt. Let me do one thing. Let me change the range of the distortion from 3% maximum to 1% maximum. So I will be reading the 1% over there. So I'm going to wait the deflection of the meter up to maximum 1%. Let's repeat the test. I'm going to increase now the input signal and monitor the distortion, and after that I'm going to read the maximum voltage swing at 1%. There you are, 1%. And I'm reading here is that is 10, 11, 12, 13. That is a 13 volt RMS, and taking 49 watt at the power meter. So let me compute that. Let me put the input to 0. Let me power off first. Where's my calculator? And there you are. So we got there is 13 multiplied by 13. That is the maximum voltage swing at the resistive load at 1% distortion, and divided by the 8 ohms load, and it gives you 21.125 watt RMS. Let me record that temporarily, just I don't want to forget it. So we've got at 1% distortion, that is a 13 VRMS, and the power at that time is like 21.5 watt RMS. Okay, so let me remember that. The next is I'm going to read the maximum power when the distortion is 10%. So I'm going to change the setting to read 10%. I can choose the 10% here, but I'd rather choose the 30, so that I just only need to read the meter in here. Other one make the meter deflection into the maximum, because I'm not so sure what's going to happen when I crank the input to its maximum. Alright, let's do that. I'm going to increase the amplitude now and monitor the 10% distortion. Alright, it goes up. There is a 10% distortion, and I'm reading here like 18 volt RMS, and that is the waveform on the oscilloscope, and picking up 65 watt on the power meter. So let me put it down and try again. Okay, let me do one thing. Set the range to 10%, lower down a little bit. Something smell burning. Okay, there you are. That's what I'm telling you. It's always heat, so I need to be very careful of the input. And the same reading, 10% distortion. We got 18 VRMS output at the speaker road. That's the waveform, and taking up 65.33 watt. Let me compute that again. That is 18 multiplied by 18 divided by 8, and you get 40.5 watt RMS. That is the maximum power that I can get from the Nathan amplifier with 8 ohms resistive load when the distortion is at 10%. That is at 10%, and we get 18 volt RMS, and the power is a 40.5 watt RMS, and we get 65.33 at the power meter. Okay, so what I'm gonna do with this formula in here, this data, let's see. The next test that I'd like to see is about the Nathan amp frequency response. So we have an output signal of what's the value is, come on, focus. That is 1.026 at 1 kilohertz, and that is exactly 1 volt RMS on the automatic distortion meter as well. In order for me to get the frequency response, what I'm going to do is that I'll just monitor, this is 0 dB, and then let me put back to 0 dB, and then I'll change the frequency from 20 hertz to 1 megahertz, and monitor the deflection of the meter going down up to, come on camera, focus please, monitor the signal up to this 3 dB. I'm going to shift now the frequency and monitor the deflection. So you can see that the frequency is increasing. Okay, increasing, and then change the setting. Let me change my oscilloscope setting too. Okay, and okay, there is a big deflection, so I'm going back to 0 dB. Okay, and then where is the 3 dB? Yes, so come on, there it is, and the frequency is above 700 kilohertz when the signal goes down to 3 dB. The next test that I'm going to do is to see the distortion at different power levels, as well as the the collector current of the power transistors, and also what's the reading of the base to base of the power transistors at different power levels. So I'm going to increase the amplitude at different voltage swing at the load, and determine different parameters: the voltage swing, the distortion, the collector current of the power transistors, and also the base-to-base voltage. Let's see that. Let's see it at 1 volt RMS. The distortion is about 0.04%. That is 0.1, and the range is 0.1. So that is like 0.42 or 0.44%. So I'm going to increase that to 2 VRMS. Focus please. That is 2 VRMS. And then the distortion goes up to 0.064, and we get let me put that into millivolt. We get 25 millivolt across the emitter resistors. I'm going to convert that into current using Ohm's law. I have to write it down. Hang on. Okay, continue the test, and I can arrive to this data here. So this is the power, and this should be the voltage swing by using the power formula, and this is the distortion at different power levels, and we get here the collector current, and also the base-to-base voltage of the power transistors. So with this data, I have a better understanding how the Nathan amp circuit works. It's now almost 10:30 in the morning, and it has been 3 hours since I started the test, and I get the initial data already, which I have written in here, including manual plotting of the frequency response here. What I'm saying is that the last thing that I have to do with my prototype number 1 is I'm going to test it sonically. And we'll see and hear Nathan amp prototype number 1 music performance with my YouTube video. Let's see it. I met my first class. Her name is start with, let me jump in that. J. Yeah.
Fly me to the moon. So much for my happy end.
Cut off the power of the whole system, so that it will minimize the standby power that will be less than 1 watt. Okay, so I completed the right channels, and I'm about to test it electrically before I'm going to subject it functionally with live music.